Welcome to the third module of Unit 1, Earth's climatic system in the climate change and adaptation subject. Here we are going to see how the global wind systems work. So global wind system, let's assume the Earth as a spherical object and not moving. In that case, what will happen? So when the sunlight comes in the equator, you can see that, so it will be evaporated, it will be lighter because hot air is lighter than cold air. So lighter means it will move upwards, and to replace that place, so air has to come from outside. So you can see from North Pole or from South Pole, air is coming in, and so there is a circle like this takes place, both northern hemisphere, southern hemisphere. So this way you are supposed to expect two circles. The air is going upwards in the equator, and from poles the cold air is coming to replace that position. And as you go upwards, it becomes cooler. Again, it moves back to the pole, and that's how the two cycle is expected. But two things happen here. First of all, Earth is not a spherical object; it's spheroidal object. So that means what? Toward the equator, it is more bulged out compared to the poles. And second thing is that it is also in motion. So because spheroidal shape, so there is not enough opportunity for this, or enough strength lying in this wind, which is go upwards from the equator to reach the pole, nor there is enough force available in the wind from the pole to come all the way. So the cell will not be complete cell from the pole to equator, it will be broken. So that is what leads to triple cell model, not a single cell model. So it will be given 3 cells. We'll see the next slide. The triple cell model. So what happened here? You can find that ITCJ is mostly equatorial region, intertropical continental zone, convergence zone, intertropical convergence zone. So why it is so? Because both northern and southern hemisphere, the hot air is being pulled up towards the troposphere, to higher altitude, okay, and it replaces back from both northern and southern hemisphere. So this is a convergence of both north and south pole. That's why intertropical convergence zone. So now what happened? The first part of this called Hadley cell, where, as we saw the previous picture, the air is not, cold air is not coming from the pole to the equator. In fact, it is coming somewhere mid latitudes, around 40° latitudes. So from there it is able to come, because longer distance is not able to come because of the, not because of temperature, because of the force available, because the rotation of the earth, and it doesn't have enough centrifugal energy to come and reach there. So so there is a smaller cell generator called Hadley cell. So Hadley cell, it is named after George Hadley. It's a tropical atmospheric circulation that is defined by the average over longitude, which features rising motion near the equator, poleward flow around 10 to 15 km above the surface, descending motion in the subtropics, and equatorial flow near the surface. The circulation is intimately related to the trade winds, tropical rainfalls, hurricanes, subtropical deserts, and the jet stream. We will see about these things. So this is how it happens. You can see the Hadley cells, and it takes place in both northern hemisphere, southern hemisphere. Now, next part of the next little up of that, higher latitude, you'll say Ferrel cell. What is Ferrel cell? Here, because of this air is coming, wind is coming from subtropical jet streams, STJS, there is subtropical jet stream, just like ITC jets and subtropical jet stream, and top will be polar front jet stream. We'll talk about that more details about jet streams. So now, because of the air is coming, wind is coming from upwards and downwards from STJS, so naturally there will be a depression takes place. And now there another cycle takes place that is called Ferrel cell, where further higher altitudes, so the around 60° altitude, so it is again in northern altitude and southern altitude, it goes upwards and again returns back toward the mid latitudes. So that is the Ferrel cell. From higher latitudes again comes back to mid latitudes. That is the Ferrel cells. And then again top, what happened? Pole is cold, so now there's a PFJS, polar front jet stream, that takes place because pole is cold. So from there it condenses, and that is low pressure zones created at around 60 degree latitude. So that to replace that, it again comes back. So there will be very, very weak polar cells. Okay, so this way the Hadley cell, Ferrel cell, polar cell, and that is also the southern side, also the same thing, you can experience that. So because of what will happen, because of the different pressure zones are created, because of heating, cooling, like this. So then heating takes place in the equator is due to sunlight, and cooling takes place in the pole due to lack of direct sunlight. So this way, this temperature difference there. But in between this the high or low pressure zones, not because of heating and cooling, is because of pressure differences, because of rotation of the earth. That's why it's get created. We'll see how it created. So now you can see in the central warm moist air rises, and when it rises that, so now cold dry air sinks from tropical regions, that is a horse latitude or mid latitude. Again cold moist air again rises. It is not it rises, but it's not warm air, so it doesn't have much moisture in that. Again, to compensate that, there is very cold air sinks in the pole. So this is how these patterns takes place. So there are different zones get created. What are the zones? So in the equator regions, we will have low pressure, then high pressure both sides, then low pressure further higher in latitudes, and further latitude will be high pressure near the poles. So this way, high low pressure, and because of pressure difference, there will be flow from high pressure to low pressure, just like water flows from higher height to lower height, or higher height to lower height. Similarly, air also flows, is also another fluid, compressible fluid. So what happens that? So you can feel that's how the flow takes place. So toward the equator, IITCJ, we can say, this air is coming. This we are talking about the surface air, not the top airs. Top airs goes, but surface air to replace that positions are coming from this. So now, but it doesn't straight takes place exactly like this, because Earth is moving from west to east. So that's why they'll get twisted. So what happens actually, instead of straight, they'll come like this, little bent. What I bent, northern hemisphere, everything bent right. So going towards top, it begins towards the east. Going to down, it begins towards the west. Southern hemisphere, everything turns to the left, because see, this what they push is the rotation the earth creates. So this is called Coriolis force. And how this force generated? Let's see a small animation about that. You can see here, this earth are rotating. Now it's rotating west to east. Now see this force getting, instead of straight, this can turning around toward the left. This is how the Coriolis force is generated. So this is because and also the mixture of land and sea, Coriolis effects become more pronounced and more aberrated at different locations. So as you can see, northern hemisphere is going towards the right, and southern hemisphere towards the left, wherever it is coming. So what is the effect of that? Effect is that, say here you can see this left side, again right side is the Coriolis forces acting on that. So those forces which are coming, those wind which is coming toward the equator, they're called trade winds. We'll discuss more about that. And those are going toward the poles, they're called westerlies, because from west to east they're coming, both sides from west to east. See, the names are given in meteorological winds, that from where it is coming, that name comes. From west to east means westerly, from east to west means easterly. So in this case, you can find that both are prevailing westerlies are there toward the higher altitudes below the poles. Now in that case, because of the presence of this wind, so if a aircraft is moving, you can see the first part of the picture, aircraft is moving, then what happened, in equator no problem, you can go straight. But now if you are going to go to the mid latitudes, now it cannot go straight. If destination is B, capital B, then it has to go to small b. In that case, because of this effect of the wind, it will be turned around. Instead of small b, it reaches the capital B. Just like if you are crossing a river from one point to another point, you cannot go straight because the current is going to drag us further down. So in that case, we have to go a little upstream, so that even in spite of the current dragging, we will be able to reach the destinations. So the same thing happens here, because knowing well what is the current, so accordingly it may be ship, it may be flight, they plan accordingly, taking into account the wind patterns, prevailing wind patterns. So this is what is the overall circulation pattern you can find. The center, there is sinking air and in two places, and rising air and in the equator, and also the higher latitudes. And so the polar easterly will be there, prevailing westerly is there, northeast trade winds are there, the equator is there. So, and the equator area is called doldrum, and it go to around 40 degree latitudes, it is called horse latitudes, and further up around 60 degree it will be close to pole. So that's how this overall planetary circulation pattern takes place. So here just now you mentioned that wind gets a name from which direction coming from. So if coming from west, you call westerly, coming from east, call easterly. So polar easterly, naturally, because pole it's coming east, from east. So that is 90 to 60 degree latitudes, and from east. Similarly, prevailing westerlies, which is 60 to 30 latitudes, and this coming from west. And trade winds, 30 to 0 degrees latitudes, and which is from the east. So it's mostly easterly. So and these nicknames are given. Horse latitude is given at 32 latitudes, 30 degree, and named because the boat's tail and the horses had to go. So actually, this areas, most of the time, this business used to do the trades from India and other countries. They used to go and they wait for these horse latitude areas, wait for the trade winds to come, and when the winds come, they will take advantage of that and go. Without much driving, they will be able to reach there. So because of the very fast, like compared to horse movement, so that's why the word horse latitude is given. And doldrums, intertropical convergence zones, that is zones. So it is mostly near equator, but we'll see that it's not exactly on equator. It also keeps changing, because in summer time and winter time, the convergence will be going upwards or northernwards or southernwards. So it is mostly in the equator situated, and trade winds converge from north and south. It need not doldrum because the boats also got stranded here. They will not be able to move much. Then what is jet stream? We talked about the winds coming on the surface. Now what are they going on the top? They also influence the surface winds. So they are called jet stream. So if you are putting this at high latitudes, if you join all these the areas of differential wind pressures from the higher altitudes, we will be able to say that track is called jet streams. So here high speed westerly winds from high above the surface takes place, and this is what influences the bottom wind flow. And as you can see, the trade winds are also got trades are the prevailing patterns of easterly surface winds. In this figure you will be able to see that these trade winds are coming yellow and also little brownish in color, southern hemisphere. So they are coming most of east to west. So they are trade winds. And then the bluish ones are also all the westerlies, because west to east they are coming. So this is how they distribute. And you can see there's some smaller circles in between where the continent and water bodies, the difference there. So they don't flow completely. So they reflected, and they form local smaller circles or smaller cycles. So these trade winds are mostly lower section of tropospheres in the Earth equator. Trade winds blow predominantly from the northeast and in the northern hemisphere, and from the southeast from the southern hemisphere. It strengthens during winter when Arctic oscillation is in warm phase. Historically, the trade winds have been used by captains for sailing the ships and cross world's oceans for centuries and enabled European empire expansion to the Americas, and trade routes become established across the Atlantic and Pacific zones. Hence the name trade wind. The most trade routes are established based on these wind patterns. The westerly or anti-trades or prevailing westerlies are prevailing winds in the middle latitudes between 30 and 60 degree latitudes, blowing from high pressure area in the horse latitude towards the poles. These prevailing winds blow from west to the east, and extra tropical cyclones are formed here in a general manner. Tropical cyclones which cross the subtropical ridge axis into the westerly recur due to the increased westerly flows. The winds are predominantly from the southwest in the northern hemisphere and from the north in the southern hemisphere. That's what the westerlies. Now we'll have a small animation where you can see how exactly it's taking place. So this is the center where the equator areas where this most heat takes place. Because of the heads, now the wind is going to a northern and to a southern hemispheres. So now the bottom part is a cooler and top part is a hotter. So this is how the convection circulation takes place. So they are called Hadley cells. Around 40 degree north it takes place like this. Now air is 40 degrees sends north and south, and part of that is split upwards, part is downwards. See this place, you can see this is not going exactly going only towards the equators. Some portion will also reflected back to the pole regions. Similar southern hemisphere also the same thing happens. Sometimes it reflected toward the southern poles. And because of the reflection and the Coriolis force also works on that. So now there is another flow takes place. Now you see it will bend like Coriolis force. So now it bends. So and this is what the trade winds. Okay, and top also when it's going towards the northern pole, they become westerlies. So the Coriolis, as you can see the curves, and it is right towards right of their path in the northern hemisphere, left of the path in southern hemisphere. And at the pole, air is now at the poles, air is still cool, and because of heavy sinks, and it moves to southern. Now you see, now it's moving southern toward the southern from north pole toward the south and south pole toward the north. Now, so another movement takes place because of cold. Now, when they hit together, see this location you can see hitting there, both are hitting together. So now what happens here? So they cannot crush. So they go upwards. So there will be again convergence zones. So that means what? Some cloud will be generated. So now you can see there will be cloud near the equator region. There is also cloud in the near the polar regions. So and these areas will be some rainfall will take place, because wherever there is a rising of the winds patterns, so there will be low pressure zones, and that's why it will have more absorption of the moisture, and more precipitation also takes place those zones. And those areas where the sinking takes place, there will be more cold. So many of the deserts are located in such locations. So this is how the total circulation of the patterns take place. So there will be subtropical high pressures on both sides, because high zones wherever is suppression and depression taking place, where the submergence taking place, at that time it is high pressure, and where is it going upwards, then become low pressure. So this is how the pressure zones are distributed, and this is the main thing which causes the planetary movements of the wind patterns. So now you can see this figure is much more clear, where you can see how the intertropical convergence ITCJ is moving now. It's not near the equator. Summertime is going upwards, winter time is going downwards. So now all these global temperature and wind variation patterns and resulting rainfall, when superimposed by local changes due to differential distribution land and water bodies, altitude variation, and allied parameters results in a specific prevailing climatic condition in different regions of the planet. So all the climate we're seeing that is because of interaction of all these parameters, wind patterns, rain patterns, and continentalities. All the parameters play a very crucial role over a prolonged geological history to form a particular type of climate zones. As you can see in this figure, this point marked here, it is sometimes moving up or downwards because of the differential heating. Because sun is rotating around the earth is rotating around the suns in elliptical orbit. So sometimes when the northern hemisphere tilted toward the sun, it will be summer. Sometimes tilted away from sun, it will be winter. So correspondingly, the other hemisphere will be summer and winter. So this way, the heating, differential heating also makes difference between the wind pattern changes. So not necessarily fixed, although around the equator, but it will not fixed on the equator. It also changes. Thank you.